There are many design considerations for high cell count applications when it comes to battery gauging and protection. I will cover the key protection and safety parameters that you should care about. Let's look at a few of the protections for a battery pack. The most basic protection is overvoltage. Why does this matter? For lithium-ion batteries, charging above the rated voltage causes lithium plating, which reduces the capacity due to the reduction in the free lithium ions. There is also the possibility of dendrites forming, causing a short between the electrodes. A protector monitors the cell voltage of each cell in the stack. The overvoltage threshold depends on the cell chemistry and the datasheet parameter of the cell vendor. The delay, hysteresis, and output control for the FET depends on the system configuration. An example of a high-side FET protector is the BQ7718XX series, with many different threshold options. If you don't see one that meets your needs, let us know and we can potentially make one that does. The device can be used together to cover 5S through 20S or even higher cell count applications. The next most common cell protection is undervoltage. Lithium-ion chemistries can have a breakdown of the electrode materials if they are over-discharged or stored for extended periods of time at too low of a voltage. Because of this, monitoring of the individual cell voltage is needed, and the discharge FET needs to open when the CUV, cell undervoltage, is reached. The cell undervoltage threshold varies depending on the cell chemistry, so again, one protector doesn't fill all applications. The BQ77905 is a simple protector with multiple options and is stackable for high cell count applications. Again, if you don't see a version of this part with the thresholds you need for your application, please let us know. Protection is also needed for excessive currents, especially for high cell count applications where additional power is available. Since pack terminals can be exposed and are at risk of being shorted together, a short circuit or SCD protection is needed. Sometimes the fault is not due to an external short but from a resistive failure that can still cause high currents, or an overcurrent in discharge or OCD event. Some applications may also need protection for a fault in the charger, or an overcurrent in charge OCC event protection. To sense the current, the protector or integrated protector gauge uses a low resistance sense resistor. The device measures the voltage drop from positive and negative terminals of the sense resistor when current is flowing to determine both the direction and magnitude of the current. This information is used by monitors and gauges for current measurements, as well as to disable the charge and discharge FETs when an SCD, OCD, or OCC event occurs. Not all protection devices include all three thresholds, and some have multiple thresholds with different response times. Two examples of protectors are shown with the BQ77905 and BQ77915 families. With the BQ77915, the OCD thresholds are available with different delay options. If your application needs a different or more specific protection threshold and delay, again, please contact us. Lithium-ion cells are complex chemical systems, and like most chemical reactions, they are sensitive to temperature. Unlike lead acid and NiCad, lithium-ion does not like to be charged when cold. Cold temperatures reduce the current carrying capability of the cell, reduce the effective capacity, and makes lithium plating more likely. One standard, JEDA, addresses this problem by mandating that lithium-ion cells not be charged below 0C. However, some battery manufacturers and systems have different requirements and want the secondary protector to allow charging at a slightly lower threshold, have the primary protection in the gauge, or as well as a smart charger to take care of the first level of protection for cold charging. At high temperatures, there is the possibility of thermal runaway, where there is positive feedback for current, temperature, and resistance increasing to a point where it is uncontrollable and potentially dangerous. JEDA also addresses this case, and typically charge is reduced when temperatures reach 45 degrees C. Again, many systems let the primary gauge protector and smart charger handle this condition, and the secondary protector is there in case of a failure. The temperature is detected by the protector sensing the voltage at a pin connected to a negative thermal coefficient thermistor, or NTC. The NTC is placed in the system where the temperatures may become critically cold or hot, As the temperature increases, the NTC resistance decreases, and the protector monitors the voltage across the NTC, calculates the temperature, and takes the action based on the threshold set based on the over temperature in discharge, over temperature in charge, under temperature in discharge, and under temperature in charge. Many options for the thresholds are possible, and a few are shown here for the BQ77905 family. In summary, the protector is needed for a lithium-ion based battery pack and can be used by itself or as a secondary protection with a gauge or monitor. 3 different product families are shown here, with the simplest device being the BQ7718 family, providing cell overvoltage protection only. As with many engineering problems, there are a variety of ways to solve them. These families give you choices depending on your system needs. Up till now, we have only discussed protectors. All of the protectors are stackable, so they can be scaled to meet the cell count needed in the systems we discussed. The protectors we discussed are usually the second level of protection, and the first level of protection comes from a monitor or a gauge. If you want to communicate the cell voltages and currents to an MCU for system-level decisions, but don't need a prepackaged gauge solution, then a monitor may be the right choice. If you need more flexibility on the thresholds and timing for protections, both a monitor and a gauge plus protector will give you that ability. Using the example of the BQ769X0 family of monitors, these devices provide a way to measure the individual cell voltages, current, provide cell balancing, die temperature, and they are able to communicate this information to an MCU. That sounds like a lot of information, and it is. It can be used to gauge system performance, diagnostics, and estimate runtime. However, the gauging function is not done with a monitor.